Hello dear student friends, I welcome you all to this video on student t-test. So this is another video in the series of biostatistics and test of significance. So t-test is one of the important test of significance, and the other name for this test is student t-test. So let's start this test, how to apply, when to apply, and what are the conditions for which we need to apply this test. So you can just see there are two formulas shown over here for the t-test. One is, this is the t-test when we know the sample mean and we know the population mean, or if the same sample is used before and after intervention. This formula is used, and this is the formula for two different samples, and we are comparing the mean. So x1 bar is the mean of first sample and x2 bar is the mean of the second sample, and S is the standard deviation. So like this, we have to calculate the t-test and interpret. So it is same like z-test. Z-test is applied when the sample size is more than 30. T-test is applied when the sample size is less than 30. So this is again for quantitative data, because we can see there is a mean. Mean is calculated in case of the quantitative data, and it should have a normal distribution. So coming to t-test, it is the alternative to test of significance of difference between two means. So we have seen the test of significance for difference between two means. So this is an alternative to that. But t-test is commonly used. Test of significance for difference between two means is not commonly used, and it is applied to quantitative data. And there are two types of t-test. Why there are two types? Because depending on the sample and sample mean. Suppose you have taken a group of people or group of children who are suffering from anemia, and you have calculated the hemoglobin level before giving iron to them. So before intervention, you have the mean, and you give the intervention, and again you get the mean. So these are the two different means from same sample. So in that case, we apply the paired t-test. Suppose you have two independent samples, like one group with one mean of hemoglobin and another group with mean of hemoglobin. So you want to compare between these two means of hemoglobin from two different samples. So we use the unpaired t-test. So please don't get confused between the paired and the unpaired. So paired t-test is for the same sample before and after intervention, whereas unpaired t-test for the two independent samples. So it can be before intervention or it can be after intervention, but samples are different. They are taken from different populations, and we are comparing between their means. So coming to the paired t-test, so again you will find here the D. The D indicates the difference between the means before and after intervention. SE indicates the standard error of difference between means. So this test is applied when there are pairs of observations, when the observations are made on same individual or same sample, before and after intervention to some influence, or when tested by two different methods. So like this, we go for the application of the paired t-test on the same sample before and after intervention. So these are the following steps. So first, we need to, any test of significance, first you need to state the null hypothesis and alternate hypothesis. So null hypothesis says that there is no real difference between the means of before and after observations. So first step is to calculate the difference in each pair of observations. So I have one example after this explanation, that we need to find out the difference. The x1 is the before intervention value, x2 is the after intervention. So you have to take the difference, and that will come to D. So you will get the D for each observation. So you have to find out the mean of this difference by summation of D by number of D. So like this, we get the mean of the difference between the two observations. Find out the pooled standard deviation. So here again we have the D from one sample and D from the after intervention sample, and we calculate the standard deviation. Why we calculate standard deviation? Because it is required for calculating the standard error. So standard error is equal to standard deviation by root n. Now we calculate the D. This is the difference between the observations, and the standard error of observations between D. So there are three things which are required to calculate T. First is the difference between two observations. Second is you have to calculate the mean of this difference. Third, you have to calculate the standard deviation. And fourth, you have to calculate the standard error. So the difference and standard error, these are the two things required for calculating T value. After calculating T value, we go for calculating degree of freedom, which we have seen in case of the chi-square test also. But the formula here is n minus 1. So this is the paired t-test where the formula for calculation of degree of freedom is n minus 1. What is n? N is the number of observations. Now, after calculating t value and degree of freedom, we refer to the t table and find out the probability p value for corresponding calculated t value and at particular degree of freedom. So if your p value comes less than 0.05, it means that it is significant difference and null hypothesis is rejected. If the p is more than 0.05, the null hypothesis is accepted. It means that there is no real difference between the two observations. Now come to an example of paired t-test. A group of 7 patients of rheumatic heart disease with distension of abdomen due to ascites affecting breathing capacity were calculated. So breathing capacity is a quantitative type of data. Could the change noted in the breathing capacity given in the following table be attributed to treatment? So this difference of breathing capacity before and after, it is in the liters per minute. Before and after, is it same or different? We need to find out with the application of the t-test. So here we apply the paired t-test because the sample is same. So first we need to state the null hypothesis that there is no real difference in breathing capacity before and after treatment. Alternate hypothesis will be there is a difference in breathing capacity before and after treatment. So first we need to calculate difference for each observation. So this x1 and this is x2. So 132 minus 102 comes to 30. So likewise for all 7 observations, we have to find out the difference, that is D. After this, we need to find out the mean of difference. So summation of D by N is that. So summation of D, this comes to 121 divided by number of observations are 7. So 17.28 is the mean difference or mean of differences. Now we have to calculate the standard deviation. So standard deviation for calculating the difference between means is summation of D minus D. So this is D1 and D2. So this is the difference between the observations, and then we have to calculate the standard deviation. So the standard deviation will be calculated by this, so it comes to 8.83. Now we have to calculate the standard error. Standard is equal to standard deviation divided by root n. So standard deviation is 8.83. Then root n, root of 7 is the sample size, is 2.64. So standard error comes to 3.34. Now we have to put up these values of standard error and difference between the means here. So 17.28 is the difference and standard error is 3.34. So is equal to 5.17. So like this, we calculate the t value. So please remember, you have to find out first difference. Second, you have to find the mean of the differences. Then third, you have to find out the standard deviation. Fourth, you have to find out the standard error. And fifth, you have to put up the values in the formula of t and calculate the t value. So our calculated t value is 5.17. Now we need to calculate the degree of freedom. So it is n minus 1. So 7 minus 1 is equal to 6. Now we need to refer this t value for this degree of freedom to the t table. So by plot table, p value for t 2.45 is less than 0.05. Actually, it is the 5.17. We'll just see in the table. So calculated value is the 5.17. And table value is the 2.45. So our value of 5.17 is more than the table value of t. So it will be a significant difference. So p value will be less than 0.05. So calculated value, that is 5.17, is more than the table t value. That's why it will be a significant difference. So treatment has the effect over the breathing capacity. After treatment, the breathing capacity has improved. So null hypothesis, which says that there is no real difference before and after treatment, is rejected, and alternate hypothesis is accepted, and it is concluded that the difference is because of treatment, and it is a significant difference because the p value is less than 0.05. Now coming to the unpaired t-test. So unpaired t-test we apply when we have two different independent observations from two samples. So in such case, we go for the t-test. So again, the steps: first, null hypothesis, no real difference between the means of two samples. Then calculate the difference again. Then calculate the standard deviation. Then calculate the deviations from the means, and then calculate the standard deviation. But before starting calculating standard deviation, we calculate the variance or the combined variance. So that is done with the help of pooled sum of squares of the differences divided by pooled degree of freedom. So degree of freedom in case of paired t-test here will be n1 plus n2 square. So like this we calculate the standard deviation. So if you take the variance calculated, if you want to calculate standard deviation from the variance, we need to take the square root of the variance. So that will give you standard deviation. And then we have to calculate again standard error of difference between two means. So that is in case of unpaired t-test, it is SD into 1 by under root 1 by n plus 1 plus 1 by n1 plus 1 by n2. So like this we calculate the standard error, and then we calculate the t-value with the differences in the means divided by standard error of difference between means. So then we have to find out the degree of freedom. So in case of paired t-test, it was n minus 1. In case of the unpaired t-test, we have two different samples. So degree of freedom is equal to n plus 1, n1 plus n2 minus 2. So like this, we know we get the degree of freedom, then we get the t-value, and then we need to refer to the table for the calculation of the probability or p-value. If the p-value is less than 0.05, then null hypothesis is rejected, alternate hypothesis is accepted. If the p-value is more than 0.05, the null hypothesis is accepted and alternate hypothesis is rejected. So these are all the steps in the calculation of the unpaired t-test. Now let us see the example. There are two samples, ESR of 15 male and 10 female. So this is two samples. Patients before start of the treatment is given below. So they have not started treatment, and they have the values. Now you want to know whether these two values of ESR are significantly different or not, or it is by chance. So these are the ESR millimeters per hour are given for the males. 15 males are there and 10 females are there. So now we have to see this calculate. So what we need here, x1 bar, that is the mean of first sample, and x2 bar is the mean of second sample, SD1 standard deviation of first sample, SD2 that is standard deviation of second sample. Now we need to state the null hypothesis, no real difference between means of two samples. So we have to calculate the difference, x1 bar minus x2 bar is equal to 94.9 minus 85.73, so it is 6.17. So this is the difference. Now we have to calculate the standard deviation. So that is calculated with the help of square root of variance. So variance is equal to summation of x1 bar minus x1 bar minus x2 bar, summation of x2 minus x2 bar. So like this we calculate the summation of the differences in the observations, and then we have to divide it by with the help of degrees of freedom, that is n1 plus n2 minus 2. So like this we get the value of the combined variance, that is 487. 487 is the combined variance, and standard deviation will be square root of the 487, that comes to 22.08. So with the help of this standard deviation we calculate the standard error. So standard error of difference between two means is equal to standard deviation into square root of 1 by n1 plus 1 by n2. It is not the square root, it is already in the under the square. So it is 1 by n1 plus 1 by n2. So we put up the values, then calculate. So standard error is 9.01. Now write down the formula for t, write down the difference, and then write down the standard error of difference between two means and calculate the t value. So calculated t value for this example is 0.68. Now calculated value is less than the table value of 2.8 at 23 degrees of freedom. So we need to calculate the degree of freedom as n1 plus n2 minus 2. So n1 is 15 plus n2 is 10, 25 minus 2 is equal to 23. So 23 is the degree of freedom for this example. At 23 degrees of freedom, we have the table value of t as 2.8, but calculated value is 0.68 and it is less than the 2.8. So it means that there is no significant difference. P value is more than 0.05. So it is insignificant, means both the values are different by chance, not by any external forces or external factor or by any intervention. So this is the table of T. So you can see here in this first column, the degree of freedoms are given 1, 2, 3, like that to 1000 they have given the degree of freedom. Even the Z value is also given here. And here the P value is given. This is the P value. And these values are the value for the T. Like we have our example 23. 23 degree of freedom was there and our calculated value was 0.68. So 0.68 you can just go on seeing in the 23. See here it is 0.68. So 0.68 the T value is 0.05. Sorry 0.5. So it is not less than 0.5. It is more than 0.05. So this P value is exactly you can get the exact P value at 23 degrees of freedom is for T value of 0.68 is 0.5. So it is more than the 0.05. That's why it is insignificant, or P value is more than 0.05. That's why it is considered as insignificant. So likewise for the degree of freedom 1 also. For 0.05, where is the P value for 0.05? We have the, see here, it is the value for 0.05. So it is the 12.71. We need at degree of freedom 1, the T value of 12.71 or more than 12.71 to get the P value of less than 0.05. So after this value, the P value decreases. So like this, we need to read the table of T and find out the corresponding P value for a particular value of T for a particular degree of freedom. So like this, we apply and calculate the T-test. T-test is very simple, but the calculations are a little bit lengthy. You need to remember the steps in each type of paired and unpaired T-test. First, you need to remember in your example which type of T-test should be applied, whether it should be paired T-test or it should be unpaired T-test. That is the very important step in application of the T-test. And then you have to remember the formula for each type of T-test and calculate the T value, then calculate the degree of freedom and see the table of T distribution, and then calculate the P value and conclude with the acceptance or rejection of the null hypothesis. So these are all the steps, and these are the this is all about the T-test. It is very simple. It is very easy. You need to do the practice. Just take any example and do the practice on paper. Then it becomes easy for you to remember and calculate the T value and refer the T table. So this is all about the T-test. Thank you very much.